So we first begin with question 1 where we use dictionary. This is the code that I've written. We have defined the student information in the variable tuples, which is a list of tuples, and we defined the function of converting tuples to dictionary, and the resulting output is as per requirements. Question number 2 is substring. So this is the code entered. Here we are getting the input from the user. The input that I'm providing is Poonam. It has O as multiple characters. So the longest substring that we derive without repeating of characters is Onam with length of 4, whereas the original string is of length 6. Next, we move to the multiple regression system. Here, the data set used is the Boston data set, which is the Boston housing data set. It is trying to find the median valuation of owner-occupied homes based on several different factors. So this is the skewed distribution of the original data. We normalize the distribution of the data set. This is the pivotal feature that was identified pertaining to the median valuation of owner-occupied homes, the MEDV, which is the target variable we are trying to achieve. And this is the regression model that was fit based on the input provided. Based on the model fit, when we calculate the R-squared error and the RMSE, the R-squared error is 0.8. So, and the RMSE is 0.02, which means the model is a good fit to our use case. Next, we move to question number 5, which is the data analysis and classification approach. Here we used a data set which includes both numeric and non-numeric features, which is the bank data set, and we are trying to identify if the customers have subscribed to a term loan or not. So here, if you look at the code, we have read the data, we have identified if there are any null values associated with it which we may want to remove or reassign the values. Here we are converting the categorical features into numerical values. The correlation between the features is identified, the positive top 5 and the negative 5 correlated features. We are identifying the x and y variables, our predictor variables, and the target variable. Here we are dropping 2 features which are contact and previous outcome, which are not important to get the output or the result that we are looking for. The training and test data has been split appropriately, and we have fit the Gaussian naive-Bayes model, the linear SVM model, and the k-nearest neighbor model, along with computing the metric score of each of them. So based on the results obtained, we find that we have 100% accuracy using naive-based approach and SVM linear SVM model. However, our accuracy is slightly reduced when we use the k-nearest neighbors, and it falls down to be 0.85%. However, overall, we can say that the data set used and the model fit are most accurate. And just to note, the test and training data set is divided in the ratio 80% training and 20% test set, which is identified here. Next, we go to the last question, which is clustering. Here, the data set used is diabetes-based data set. Basically, we are trying to predict if the patient has diabetes or does not have diabetes. If we look at the code, apart from importing the different libraries that we would need, so these are the different clusters that we identified, with glucose being the common factor. And this is the pairwise plot of all the features across all the features. We have kept glucose as the primary parameter to plot the 4 cluster graphs. The elbow method identifies that 3 is the most optimum number of clusters that we could use to get the most accurate results. So here we can notice that we have the positively top 5 correlated features and the negatively correlated features. Any null values associated with our data set, and we identified that there are no null values associated with it. And based on the score, which keeps changing, the maximum that I could get was like 5.4. 0.55 was the maximum that I could identify. And to identify that, one thing we need to note is I've used 3 clusters as my cluster size, and the sample size of data that is used is 40, which have given me the best result of 0.55 at a different approach when I ran the code on a different time. So when it comes to reading the code, here we have all the data identified, read, and the x and y features identified, x being a predictor variables, y being a target variable. We identify the correlated features associated to our target variable, which is like the outcome of the patient having diabetes versus not having diabetes. This particular piece of code identifies whether there are any null values associated with it, so we can either replace them with 0 or remove them overall. This cluster identification section identifies the different graphs, the cluster diagrams that we came up with, and this pair plot identifies the clusters obtained for matching each feature with all other features and itself across the board. So all the features form the x-axis, whereas all the features also form the y-axis, and that's how we get multiple pair cluster diagrams under the pair plot. This particular section gives us the elbow method, which identifies the optimal number of clusters to get the best performance of the model derived, and this helps us visually look at it in a graphical form. This particular section pre-processes the data set to standardize its distribution in case it gets skewed. Here we are performing the clustering with the number of clusters assigned as 3, and we are evaluating the result using the Sillout score to ensure that the model predicted based on the using the test data set on the model fit using the training data set is good or not.